In this video, we are going to discuss vertical and horizontal asymptote. What is vertical asymptote? That's the asymptote toward which the graph is gonna run. So on these graphs, I have asymptote with red color, red dashes, VA, vertical asymptote. Graphs are running, but never crossing. So how we're going to figure out where is the vertical asymptote? Let's say take example of f of x is equal 1 over x squared. So the domain that cannot, the value of x that cannot be in the domain, which means the value of x at which the fraction in denominator become 0, that is our vertical asymptote. Let's say at the rational function 1 over x squared, our x cannot be equal 0. And that's a value that is not acceptable by domain on the graph is represented by vertical asymptote. So 1 over x squared, this x is equal 0. This vertical line is our vertical asymptote. Let's take another example. F of x is equal x over x squared minus 9. So when x squared, we have x squared minus 9, that means the denominator cannot be equal 0, right? Because we can't divide by 0. So x squared minus 9 cannot be 0, which means x squared cannot be positive 9, and x cannot be plus or minus 3, which means in this graph we have two vertical asymptote plus 3 and minus 3. This is the first one, and here is the second one. So we provide these red colored dashes here on the graph, and as you can see, the graph is running towards asymptote but never crosses. Here also graph is running towards asymptote and never crosses. And this graph also in the middle, as you can see, running towards asymptote negative 3 and positive 3. And it's going through x is equal 0. That's because of this x here we have. This x. Let me see. So because of this x, it's running through x is equal 0. And this is our the third line in this graph. It's broken into 3 pieces because of these two asymptote, positive 3 and negative 3. So remember, we on the interval with the domain, we would say the domain for the graph, like for the rational function like that, the domain interval for the domain is going to be negative infinity, negative 3, and then negative 3, positive 3, and then positive 3, positive infinity. Here we go. This is one piece, this is another piece, and then this is the third piece. Okay, one graph is on this line, another graph is on this interval between negative 3 and positive 3 asymptotes, and third graph is between 3 and negative 3 and positive infinity. Okay, next example, f of x is equal, let's say, 3 over x divided by the x plus 4. Okay, so what do we have in this case? In this case, either x cannot be equal 0, this is this x, or x cannot be equal negative 4, right? This is this x. Okay, so we have two asymptotes. We move a little bit. Okay. So -4, our asymptote. Which is gonna be 1, 2, 3, 4. And then another asymptote is equal 0, which is going to be this one. And this is how the graph is going to look like. So we have the 3 breaks, right? From -infinity to -4, from -4 to 0, and then from 0 to +infinity. So one is going to -4, vertical graph. And then between -4 and 0, this gonna be graph like this. We will learn how to build the graph, okay, at the end. So right now we're exploring this asymptote. So right now, just trust me, this is how it's gonna look like. And the asymptote, another one is x is 0, vertical asymptote. So it's running towards this 0 asymptotes. Okay, this is how the graph looks like. Okay, now let's move to next example. Move a little bit down here. There we go. So moving to our next example, let me see what we have. F of x is equal x minus 1 over x squared minus 1. Okay. So what do we have here? In this case, our x cannot be equal plus minus 1, correct? X cannot be equal plus minus 1. All right? But now we can simplify this problem. Let's see how we are going to simplify. Based on whatever is given, with the x cannot be equal plus minus 1. So we would have 2 asymptotes, right? One would be -1 and the other one would be +1, correct? But here is something interesting we are going to explore. So having x minus 1 over x squared minus 1, I will have x minus 1 here. X squared minus 1 is equal x minus 1 times x plus 1. Again, remind you for a minute, a squared, the formula a squared minus b squared is equal a plus b times a minus b. Yes, my x squared is a squared and b squared is 1 squared. Therefore, my a will be just an x, my b will be just an 1 and x minus 1. Here I have it. So it doesn't matter if I put first x plus 1 or x minus 1, because between them multiplication. It's same thing if I would say 3 times 2 or 2 times 3. Doesn't matter at all. So based on a squared minus b squared, I can open this formula x minus 1, x plus 1. Next, I can cancel x minus 1 with x plus 1, and as a result I would have 1 over x plus 1. What does that mean? That positive 1, so from here x cannot be equal negative 1, right? Only, which means this positive 1 case is disappearing, which it's not going to be vertical asymptote. I am cleaning here. So it's falling out as an asymptote. And the only asymptote we are going to have, this is going to be negative 1. And our graph is going to look like this, running to vertical asymptote negative 1. But what's going to happen to our this positive 1? Somehow at the beginning we had x cannot be equal plus minus 1. So x plus 1 that we canceled, we got canceled here in the simplification and got rid of it, is going to be looks like it's treating and it's not a vertical asymptote. What do I mean by that? Let me explain this. Let's say I'm walking and in front of me somebody digged the hole. If hole is too big, right, then I can't jump over. But if the hole is small, I can either jump over that hole or fill up that hole and just walk by, correct? This is how approximately how it looks like. So this plus 1 vertical asymptote kind of been treated as an asymptote and is disappeared, and now it's left from it so just so you know that so we can it will remind us about plus 1. It's gonna be our hole. It's here, this piece is here, it's gonna be only as a whole. Okay, so it's not gonna be vertical asymptote anymore, but it's going to be whole. If we wouldn't have this x minus 1 cancelled, disappeared, and here would end up only x plus 1, then our positive 1 vertical asymptote would survive, and we would have broken down into 3 pieces, right? Into 3 parts. Okay, let me explain another example. F of x is equal x squared minus 4, and I have x minus 2. So based on domain, x cannot be equal positive 2, correct? Because of here. Because if x is positive 2, we get division by 0. All right. This is my asymptote. It's going to be positive 2. Positive 2. Here it is. But let's see. I'm looking here, so it looks like we can do some simplification. So x squared minus 4 over x minus 2, that is equal. X squared minus 4, it's the same. I can write down as a squared minus b squared. B squared is going to be my 2 squared, right? If I can write down 4 as a 2 squared. Which means it's going to be x minus 2 and times x plus 2 and dividing by x minus 2. So x minus 2 is cancelled with x minus 2, and the result is x plus 2. Okay, So what's going to happen? This 2 is practically gone because we don't have a fret here to convert to 0 when x is equal to, right? Which means as a vertical asymptote, it's going to be gone. And instead of vertical asymptote, we are going to have only whole. So x plus 2, it's a linear graph, right? Let me build x is equal, y is equal x. This is my y is equal x. Equal x, so I move by 2. And I'm going to provide parallel line. So this is 2, x plus 2. But where is our x is equal to? Our x is equal to is here. So the vertical asymptote became, from the vertical asymptote left over only a whole. That's what it is. Because it's kind of, we say vertical asymptote got treated, and there is only left the whole from that vertical asymptote. Are we good? So let's take another one more. Give me 1 second. Okay. I'm trying to find the one I wanted to use. All right. Here is the next example. F of x is equal x minus 8. And here we have x squared minus 11x and plus 24. Plus 24. So practically, we can't just looking at the x squared minus 11x plus 24. We can't just like looking at that expression figure out what x cannot be. Therefore, we are going to solve it. X squared minus 11x plus 24 cannot be equal 0, right? We are going to FOIL it. It's going to be x minus 8 times x minus 3. It cannot be equal 0. And from here, x cannot be equal 8 and x cannot be equal 3. So primarily we are looking at 2 vertical asymptotes where x is 8. 1, 2, 3, 4, 5, 6, 7. Okay, let me move it so I can draw 8. Okay. So one, 2, 3, 4, 5, 6, 7, 8. Vertical asymptote and positive 3. This is our second asymptote. This is 3. This is 8. Okay, so let's see if the vertical asymptotes are going to survive. So x minus 8. Here we have x minus 8 and x minus 3. There we go. X minus 8, x minus 8 is gone. We have only 1 over x minus 3. So what does that mean? That asymptote 8 disappeared, right? From vertical asymptote will be left only a hole, right? The only real asymptote we will have is positive 3. Therefore, the graph is going to look like this. And now from x is equal 8, we are going to have right here, we're going to have hole. Let me clean this 8 from here because it's causing confusion. So okay, and this is your 8. Okay, this is how it look our vertical asymptote. All right. Now I guess we can move to horizontal asymptote. Horizontal asymptote. Okay. Okay, let's see what's going to happen. Here I'll write down also vertical asymptote so you would know. This one also vertical asymptote. So let's find out which one we call horizontal asymptote. How to calculate horizontal asymptote. It's if vertical asymptote is running vertically, then horizontal asymptote is going to run obviously horizontally, correct? Okay. So how it's gonna work? How we gonna figure it out? So in general form polynomial, when we have a f of x is equal a n x to n plus a n minus 1 x to power n minus 1 plus blah 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 plus a1 x1 plus a 0. And the same way here, bmxm plus bm minus 1 x to power m minus 1 plus blah 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 plus bm b1 b1 x1 and then plus b0. Okay, so we are going to work with this coefficient of the highest degree. In highest degree for numerator it's going to be n, for denominator it's going to be m, and their coefficient is going to be an and bm. Here are the rule how we are going to calculate, let's say, vertical asymptote. We would look at denominator, make sure it's not equal 0. How about the horizontal asymptote? Horizontal asymptote is going to work the following way. So here is the rule. If the highest degree of the numerator, which is n, is, let me use red color because this is the rule. This is a rule. So if highest degree of numerator is less than highest degree of denominator, which is m, then my the horizontal asymptote, my y is equal to 0 is my horizontal asymptote. Y is equal 0, it's going to be this graph. This is your horizontal asymptote, right? Y is equal 0. Second, if n is greater than m, which is highest degree of n, at the numerator greater than highest degree of at the denominator, then we have no horizontal asymptote. Well, imagine this way. If the highest degree of polynomial in numerator is greater than highest degree of exponent of polynomial in denominator, then we are having kind of improper fraction, right? Because degree of numerator is higher than degree of denominator. Improper fraction. Therefore, we don't have any horizontal asymptote. While when highest degree of numerator is less than highest degree of denominator, then we have proper fraction. And the third case, when n is equal m, then our horizontal asymptote is equal coefficient a n, the coefficient of highest degree of numerator divided by coefficient of highest degree of denominator. Okay, so let's do examples. F of x is equal 9x squared over 3x squared plus 1. So what do we have? My n is, this is my n, this is my m. They are equal, right? We have the case when n is equal m, correct? And therefore, a n over bm, this is our horizontal asymptote, and that's equal 9 divided by 3 is equal 3. So if I draw the graph, this 3 it's going to be our horizontal asymptote. Okay? Let me see. what I have in 3x squared plus 1. Give me 1 second. I'm trying to figure out how graph it's going to be looking. So I'm drawing on a piece of paper and then I'll move here. Well, this is how our graph approximately gonna look like. Not exactly. Hold on, let me see if I can draw much better. Something like this. Okay. This is our horizontal asymptote. Next one, g of x is equal 9x over 3x squared plus 1. Okay. Nine x 3x squared plus 1. All right. So, how it's gonna look like this one? Let's see. The degree, our n here, and m, okay. My n here is equal how much? Equal 1, right? Here it is. And m equal 2, correct? So which case is applying when n is less than m? Here it is. So n is less than m, which means horizontal asymptote is going to be equal 0. Okay, so how it's going to look like, the graph? So horizontal asymptote is equal 0, which means this is going to be our horizontal asymptote. So it's going to come something like that. Okay, something like that. And this is going to be our horizontal asymptote that is equal 0. Okay. Next one. H of x is equal, let's take now this time 9x cubed over 3x squared plus 1. Okay, so what do we have? Our n is how much? M is how much? So n is 3, m is 2. We practically get the fact when n is greater than m, which means, here is our condition, no horizontal asymptote. So how the graph is gonna look like? Which means we can insist that our graph is gonna be continuous, right? There is not gonna be, there is no horizontal asymptote where graph should run to. No, okay? So at this point, this graph is gonna look something like that. Oh. There we go. This is going to be our graph, which means there is no asymptote at all. Okay, I hope this was helpful. And next I will record transformation of graphs.